Forward free response question. They give us that f is an increasing function and the derivative of f, and they give us that f of 0 is equal to 2. The first question that they ask us is find f double prime of negative 2, which is the second derivative. So basically, let's find f double prime of x. So this here, if you look, this is this inner thing you want to think of as u. The derivative of sine u is cosine u times the derivative of u, or times the derivative of the inside. The derivative of pi times x is just pi, so I put that in the front, plus the derivative of x squared, that's just power rule, is 2x, plus the derivative of 3 is 0, since 3 is a constant. Now that I have f double prime of x, I can find f double prime of negative 2. And if you look at this, I'm going to get pi times cosine negative 2 pi plus negative 4. When x is negative 2, negative 2 times 2 is negative 4, so minus 4. And basically what you need to see is that cosine of negative 2 pi, that's cosine of negative 360, so it's going around the full circle once. And the cosine value is the x value on that unit circle, so the cosine value is going to be that cosine of negative 2 pi is going to be 1, because the x value is 1 there, so it's going to be pi minus 4 as f double prime of negative 2. Now the next thing, that's A, we're done with A. B, write the equation for the line tangent to the graph of y equals 1 over f of x at x equals 0. So let's see what we get here. So now it's giving me another function in terms of f, and basically what you want to do here is you want to find y prime, right, in terms of f of x. And you can do it in a few ways. You can notice that this is to the 1 down here, so you could bring up that entire f of x and make it to the negative 1, and then use chain rule. And I think that's the easiest way. The other way you could do it is you could use quotient rule, with this being the top function and then f of x being the bottom function, and you'll get the same thing either way. This is not y prime, this is just y, sorry. So this is y, f of x to the negative 1. And now if I want y prime, again, I got to use chain rule. I got to realize that this is the inner function, right? F of x as a whole is inside this to the negative 1. So it's u to the negative 1. And the derivative of that is if you bring down the exponent, negative 1 times u, which is in this case f of x. And then u to the exponent gets decreased by 1, so it becomes negative 2, right? Times, now we got to remember that this was u, the derivative of u, which is in this case f prime of x. And then I just do some simplification on this. Y prime is equal to, if you like, f prime of x over f of x squared. And it's negative. And now it's asking for the equation of the tangent line at x equals 0. So this represents the slope of the tangent line at any point, at any x value. So if I want to find out what the slope of the tangent line is at x equals 0, I got to find out negative f prime of 0 over f of 0 squared. And this just takes some arithmetic now, because I have a function for f prime of x. So f prime of 0 is just sine of 0 times pi, which is just sine of 0, which is 0. 0 squared is 0, so then this is just 3. So I found out that f prime of 0 is 3. So it becomes 3 squared, that's 9. And then negative f prime of 0. Oh, nope, sorry, that's not up here. That's why I was like, a little tricky. This here, negative It's negative 3 on the top. I apologize. I found f prime of 0, so it's negative 3 on the top. F of 0 is 2, so then 2 squared is 4. And then this is the slope of my tangent line. Now I need to just write the equation for that for a line essentially, right? So I know another point on this curve is y1 over when x is 0, it's f of 0. So the y value when x is 0, I want to find out for this curve, right? I want to know what this curve looks like, y equals 1 over f of x. I want to know what this point is. When x is 0, right, y is going to be 1 over f of 0, which is 1 over, and then f of 0 is 2, is 1/2. And now I have a point, and I have slope, so I'll just use point slope form. Y minus y1 is 1/2 equals m times x minus x1, but x1 is 0 here, so it's just times x. And you could, I think, leave it like this, but just in case they want it for whatever reason in slope-intercept form, or you feel more comfortable with slope-intercept form, plus 1/2. And then this is your line in slope-intercept form. That's b. C, let the function be defined as this here, and basically you want to find the derivative at 2. So what we have here in this case is you have let's see. Can I move down a little bit? Alright, yeah. So let's see. This is part C, and let's do it in a different color so we don't get confused. Let's do it in this purple pink here. Okay, so we have f of square root 3x squared plus 4. This is g of x, they're saying, and they want you to find g prime of 2. So what you do here is you differentiate, and you need to use chain rule in order to get the derivative of this. The inner function in this case is this whole thing, right? That's u. And chain rule says that it's the derivative of that inner function times the derivative of that inner function. So let's work on the derivative of that inner function just on the outside for a second. So that inner function is 3x squared plus 4 to the 1/2. And I took the radical and I just made it an exponent to make it a little bit more clear as to how I'm going to differentiate this u, right, this inner part here. Because remember, I still have to multiply by the derivative of the inside by chain rule. So if you look again, the problem is that I got to use another chain rule on this, where this is the inside function. So that's now my new u. And it becomes 1/2 times u to the 1/2 is 1/2 u to the negative 1/2. So this becomes negative 1/2 times the derivative of the inside. In this case, the derivative of the inside is just 6x. And that's because of chain rule, right? The derivative of 3x squared is going to be 6x. And then the derivative of 4 is just 0. So that's my derivative of the inside. I'm going to rewrite that. I'm going to write it 1/2. But 1/2, right? 1/2 of 6 is 3, so it's 3x squared plus 4 to the negative 1/2. And I still have some work to do with this. F prime of this value, but though really not really, because I want to find g of prime of 2. So what I'm going to do is I'm going to skip this. I have an expression for g prime of x, so I'll just go right into finding g prime of 2 with this expression. It's going to be f prime of 3 times 2 squared plus 4 times, this is going to be 6, and then it's going to be all of it over, I'm going to bring down this negative exponent, the square root of 2 squared plus 4. And this is ugly as you can get. This is 4 times that is 12, plus 4 is 16. The square root of 16 is 4, so it's just f prime of 4. So that's not too bad. Times 6, this whole thing I found out was 4 just now, right? Let's just make sure, 4, right? 3 4s plus 1 more 4 is 4 4s. 4 4s is 16, the square root of 16 is 4. Okay, so this is g prime of 2. And now let's see, this is f prime of 4. Let's go up here, get an expression for f prime of 4. So f prime of 4, this is going to be 4 pi. Now 4 pi is two things around the circle. This is going to be 0 because sine of 4 pi is 0. 4 squared is 16. 16 plus 3 is 19. And now I have an expression for this. This is 19 times 6 over 4, which is equal to 19 times 3 over 2, and whatever that's going to be. 19 times 3 is 20 times 3 minus 3, which is 60 minus 3, which is 57. 57 over 2. And I think that they're okay with you leaving your answer like that. That's C. Now D, let h be the inverse function of f, find h prime of 2. Now here you got to use the inverse derivative function rules. So I'm going to do that above over here. We have part D. And we know, again, I could just derive this rule every single time if you're careful, f of h of x. So it actually it tells you that it's an increasing function, which means that it's going to have a derivative because it's always increasing. So it's going to pass the horizontal line test. So it having an inverse function is perfectly kosher. Now we know that f of h of x is equal to x. That's the definition of derivative. And if you ever I'm deriving the formula that they want you to use for D. You can memorize it, but I always derive it. So basically what I have here is a function inside of another function, and I could use a chain rule here to get that f prime of h of x times h prime of x, that's by chain rule, is going to be equal to 1, the derivative of x. So I just differentiated both sides of this. The left-hand side using chain rule, and then the right-hand side, the derivative of x is just 1. Now I want h prime of x. They want me to find h prime of 2. So I divide on both sides and I get an expression for h prime of x. I divide 1 by this here. f prime of h of x. And then now they want me to find out exactly what h prime of 2 is going to be. And that's going to be f prime of h of 2. But h of 2 is actually 0, and you can see that this is going to be the case because you want to find h of 2. You want to find, that's, let's say, question mark. That's what you're looking for. That's your goal, right? But you should know this rule, right? F on both sides. If I apply f on both sides, well, that f just undoes h, and h undoes f. So if f undoes h, then that means the 2 just drops out here, and I get f of whatever it is that I'm looking for originally is equal to 2. Well, what's the value? What's question mark? If you look at this here, right, f of 0 is 2. So I found out that h of 2 is 0, and then I'm really looking for, this simplifies to, let me get rid of that, that's from the other problem, h prime of 2, if I go back up to here, h prime of 2 is equal to 1 over f prime of 0, and then f prime of 0 is 3, so this is just 1 over 3, and that's h prime of 2, and that's D, and we're done.